Okay, here we go, guys. Today, this is going to be looking at problem 3 on your free response review type 2 linear motion, or as I would also call it, almost all these are referred to particle motion, where the particle moves along the x-axis. And so this is a classic one. It's got the particle moving for a particular time interval, 0 to 6. The time unit is not really given here, so we could just say seconds. It's saying the particle's moving along the x-axis. The position function is called x then, but it's not given. The velocity function is given. Let's just highlight it or circle it. And as I'm doing that, I'm also typing that into my graphing calculator. So on the right side of the screen, you'll notice that y1 is the given velocity function 2 sine of e to the x over 4, all plus 1. And they didn't have to do this, but because they could have asked you to find the acceleration function using a derivative. Now, if you want to check the chain rule here, this is a good use of it, and they've got the acceleration function right there for you, 1/2 e to the t over 4 times the cosine of e to the t over 4. And I've gone ahead and we're going to type that in as y2 on our graphing calculator. And the other thing they did give you is the starting position, x of 0 is 2. Now, problem A is find if the speed is increasing or decreasing at the time 5.5, and we're going to have to give a reason for that. That means if you just give an answer, even if it's right, but don't explain why you have that, you won't get credit. B, find the average velocity of the particle during those 6 seconds. Okay, so back to A. It is asking about the speed, not the velocity. So you can be speeding up, moving to the right. You could also be speeding up and moving to the left. So the way that would happen is if the velocity was a positive, meaning it's moving to the right, but the acceleration was also positive, that means it's going to be going faster and faster in that direction. Now, if the velocity is negative, that means it's moving to the left, and it could still be speeding up in that direction if the acceleration was also negative. So what we need to do is check and see what the positive or negative status of the velocity and acceleration are at that time. Okay, so we're going to just grab the calculator. You could do one of two things. You could graph the functions and use the trace key, or what I like to do is just go back to the home screen, grab the function by name, alpha, trace, y1. We're going to evaluate it at the time 5.5 and see what it is. Now I've got a negative 0.453. It's really the negative that we're caring about. And then do the same thing for y2. I've got a negative again. I'm going to just write it down now. Negative 1.35. It'll be 9. And our main observation is since both of these are negative, the particle is going to be speeding up. When it's moving to the left and speeding up. Okay, so we'll just give a short explanation here. The particle is speeding up when t equals 5.5 because its velocity and acceleration are both, in this case, negative. Okay, it might even be better just to not even include the negative, just say they both have the same sign. That's almost better. That way you're not trying to, they might not, you're not risking them thinking, oh, the fact that it's negative has anything to do with it. It's just the fact that they're the same sign, okay? So you might even want to put that. That's even a better way to say it, okay? Notice very little tough arithmetic here. It's about the concepts. You know what you're looking for. You gather the information and then write a conclusion. That's all they're asking for there. B, find the average velocity of the particle during these 6 seconds. Well, normally, if you were given the position function, the way to do this one would be to find out how far it went, which is x of 6 minus x of 0, and then you'd have to divide that by the time difference, which is 6 minus 0. Now, the problem is we don't know the position function, so this difference cannot be calculated by individually finding x of 6 and x of 0. We do know x of 0, but we don't know x of 6. But we do know another way to find that difference, right? This is position function x is the antiderivative of the velocity function. So instead of thinking of it like this, like what the definition of the average velocity is, let's think about how else we could calculate this. And that is, other than the 6 minus 0, x of 6 minus x of 0, that reminds me of integration. It's the definite integral of the velocity function from 0 to 6. And now this is a nice tie into something else, another concept, and that is, isn't this what you do exactly if you were going to find the average value of the velocity function, which is another way to think of average velocity. It's the average value of the velocity function. Now, once you realize this is what you have to do, everything else is going to be done entirely on the calculator. And so we'll go to our integration, alpha window 4. It's between 0 and 6. And now we want the integrand to be the velocity function, so that was y1, alpha trace 1, dx, and that's entirely done by the calculator. Now that's the integral. We still have to divide by 6, so divide by 6, and our average velocity is 1.949. Now, since the distance units and the time units are not given, there is no need to label this. Don't make up a unit if they don't provide them. Okay, so 1.949 is the numeric value. Once again, all of the computation is done by the calculator. The only thing they're checking for here is that you know the concept of average velocity and how you use calculus to find it. Okay, so all the calculation was done by your calculator. Let's try C and D real quick. Same scenario. C says find the total distance traveled. Okay, this involves integration also, but there is a difference between distance traveled and displacement. Okay, so distance traveled means including forward and backward motion during this time. How far did it go? And remember, that means we have to count all the movement as to the right or to the same direction, which means we absolute value the velocity function 0 to 6. So once again, they're just checking that you know that concept, and everything else, the answer will be computed on the calculator. So over here, integral again, alpha window 4. Limits of integrals are still 0 to 6. We just have to absolute value, and I don't know if you know this, but the quick way to get that is alpha window 1. And we got to put the velocity function inside. Okay, this is entirely done by the calculator. All right, total distance is 12.573. Again, don't label it because there were no units given, so don't make any units up. They're just wanting the numeric answer. Okay, now D is probably the longest part. It says during those 6 seconds, the particle changes direction exactly once, and we have to find the position at that time. Well, we first have to find out where it changes direction. So the key concept there is the direction is determined by the positive or negative sign of the velocity. And so let's take a look at the graph of the velocity function now. Now, we were told the domain for the time was 0 to 6, so I've gone ahead and I've made that the x min and x max on my window. What we're looking for here is when the velocity changes signs, positive to negative or negative to positive. So in my y scale, all I need to make sure I can see is the x-axis. So just make the y min a small negative and the y max a small positive. And we're on the interval 0, 6. Let's go hit the graph. And here's our velocity function. There is a crossing right here. It looks like just a little bit after 5 seconds. So we just need to get the calculator to find it. Once again, we're not going to solve this equation by hand, even though this is one that I guess we could, but you're not expected to do that. Go ahead and get the calculator to find the zeros. That's second trace. And then number 2, the crossing is between 5 and 6. So I'm just going to type in left bound 5, right bound 6, and we're going to guess about 5.1. And it gives me 5.1955, so 5.196. And that's the, and now it told us it was only going to happen once, so the graph definitely confirms that. Now what we have to find is the position at that time. So we have to find the position X at 5.196. So there's a couple of thoughts on this kind of problem here. Some students will try their best to integrate the velocity function, by hand, finding the antiderivative to try and come up with the velocity function or the position function. That would not be time well spent for 2 reasons. The primary one is this is not a function up here that any of the integration methods you've learned would help you solve. For example, there's e to the t over 4 inside of a sine function there, and no standard U substitution will work for that one. Okay, so you're going to be trying something that is a futile attempt if you try and find the antiderivative of the velocity to get the position function. What we know instead is how to find the difference of 2 position values. So for example, I'm going to write out this. And this kind of reminds me of something we saw in A. But this time, I'm going to remember that this difference is the 1/2 of the fundamental theorem of calculus, the definite integral of this time interval, 0 to 5.196 of the velocity, must give you the difference of these 2 position values. Now, we happen to know x of 0. So in addition, then, I can solve for x of 5.196 by adding x of 0 to the other side. I'm going to do that now. And now this is a calculation we can do entirely on the calculator, noting that x of 0 is 2. And so we'll go back here. Actually, what we ought to do is we should store this intersection right before we do anything else, because it's going to be used in a further calculation. I don't want to round it too much on my calculator. So I'm going to store that, and it's going to be letter B because it's going to be the upper limit of my integral. Okay, that way I've got all the decimal places I might ever want. So now I can go, my entire calculation is going to be x of 0, which was 2, plus, and then we'll just add on the integral from 0 to b. Again, the integrand is y1, which is the velocity, dx. And everything calculates to 14.135. Remember noticing all of our numerical answers from calculators have to be rounded to 3 decimal places. So if any of these, if we round any of them to 2 decimal places or just not anything less than 3, you're not going to get that answer point. Okay. So what I like to do each time in each of these videos is show you the answer key, which shows the correct answers, but also kind of what you earned the points for. Okay. So this was also, remember, these are all worth 9 points. Part A, which was a pretty short one, was worth 2 points. It's all wrapped up in, all 2 points are wrapped up in the same thing here. You have the correct conclusion and a reason. Okay, now they're not separate points. So if you were to give the conclusion that the speed was increasing but had nothing else there and didn't explain how you got it, you're not going to earn either of those 2 points. You have to have valid reasons, such as making an observation about the two values of the velocity and acceleration. B, if you have any work at all that shows you know you need the integral of the velocity from 0 to 6, you're going to get a point earned, and the second point for the final answer, which means you take the integral, divide by 6, and get the answer they have. Similar for C, if you have the integral of the absolute value of the velocity somehow written on your paper, that is 1 point, and then if you correctly compute it with the calculator, that's the second point. D is worth 3 points, it's the most. You get 1 point if you communicate that you needed to find when the velocity was 0. Okay, so really, as soon as you write this much on your paper, I think even if you didn't find it correctly, you get 1 point, just for knowing that that's when the velocity could change signs, right? 1 point if your final calculation involves the integral of the velocity. And the third point is for the answer that includes taking that integral plus 2. Okay, so there's 3 points total. Well, guys, I hope this is a good refresher, maybe helps you on some of the other problems in this topic. And we'll see you back next time on problem type 3.